Hello folks, and welcome to Adding and Subtracting Radicals. We are going to continue our journey with radicals so that we have those rad skills for the next chapter that we will be talking about. So if you take out your notes, a calculator, a pen, or a pencil to take some notes with, we'll get started. All right, so I do need you to write down this right here. A square root expressions with the same radicand are examples of what we call like radicals. Now you don't have to write the next thing down, but here's some examples of what I mean by like radicals and examples of what I mean by unlike radicals. So the first row we have what are called like radicals because the radicand 5 and that 5 are the same. Or the radicand square root of x and the square root of x are the same. Or the square root of 4t and the square root of 4t are the same. But notice in the second row that the radicands are not the same, or they don't even have radicands. So like 2 and square root of 15, the 2 is not a radicand. If I move further, this is not the same as this. Therefore, they are called unlike radicals. And we cannot add or subtract things that don't have like radicals. So here's a helpful hint, and I do want you to write this down, that when we combine like radicals, it's like combining like terms. So if you have 2x plus 4x, we get 6x because these are the same. Now, same goes with radicals. The radicand has to be the same in order for us to add the 2 and the 4 to make 6. Okay, so that's a helpful hint. You do not need to write this down, but I want you to visualize what's happening here. Like radicals can be combined by adding or subtracting. You can use the distributive property to show how this is done. So if we're going to add like radicals, you can see that if I have 2 square root of 5 plus 4 square root of 5, it would be like saying 2 plus 4 because the square root of 5 is the same in both. And I would get 6 square roots of 5. If I were subtracting, same thing would happen. 6 square root of x minus 2 square root of x would be the same thing as saying 6 minus 2, which is really 4 square roots of x. Okay? Now, just for a basic understanding, to understand the basic idea here, you don't need to write this down, but again, it's the same thing. We can take 3 crayons plus 2 crayons and get 5 crayons, and I can't draw a crayon. Okay? And that's okay because these are alike. But I can't take 3 apples and 2 oranges and get 5 of something. These are not alike, so we cannot add them together. All right, with all that behind us and all that information we know, let's go ahead and do some examples. So let's do example number 1. Let's add, subtract, and simplify the following. Now when I look at these two parts of this problem, I notice that the radicand is the same in both. And as long as we have the same radicand, then we can add the outside numbers. So 7 plus 2 is 9 square roots of 6. It would be like saying 2x plus 7x is equal to 9x. Okay? If we have like terms, we can add the radicals together. Okay? Add or subtract or simplify the following. 3 square roots of 6 minus 4 square roots of 6. Well, again, we have the square root of 6 under the radicals, so our radicands are the same. So what we can do is we can say 3 subtract 4, which is negative 1 square root of 6. Now, we also can write this as negative square root of 6 because we don't have to write that 1 in front of the square root. It's like writing an x. You can either write 1x or just an x, but it's understood that there's a 1 there if you don't see the numbers. So either way is acceptable. All right? Next example, example number 3. Again, add, subtract, and simplify. When I read this one, it just doesn't seem to go as easily as the last two. Negative 2 square roots of 3 plus 3 square roots of 27. These guys don't match up. So what I have to do is I have to simplify the square root of 27. Now that's why we spent a lot of time on simplifying, so that we're good at that. So we need to break up the square root of 27. What two radicals would multiply to make 27? Remember, one of them has to be a perfect square. Well, 9 is a perfect square, so 9 times 3. The square root of 9 becomes 3. The square root of 3, when you put that in your calculator, you get a decimal answer, so you leave it the square root of 3. Now, the number out in front here means I'm multiplying. So this says 3 times the square root of 27. So when I bring this down, I would have 3 times the 3 square roots of 3 that I simplified that into. And 3 times 3 is 9 square roots of 3. Now I can look at this, and remember, we didn't need to simplify this, so we can just keep bringing it down until the end. And when we do that, it says negative 2 square roots of 3 plus 9 square roots of 3. So now that our radicands are the same, we can say negative 2 plus 9 is 7 square roots of 3. And that would be our final answer. Okay, let's try example number 4. Negative square root of 12. That can be broken down into the square root of 4 times the square root of 3. The square root of 4 is 2. Bring down the square root of 3 because that can't be broken down. And this says negative 1 times the square root of 12. So then we can bring this negative 1 down. Times 2 would be negative 2 square roots of 3. And then 3 square roots of 3, that's already simplified. So I'm going to just bring that all the way down. And negative 2 square roots of 3 plus 3 square roots of 3 would be 1 square root of 3. Or I could just write it the square root of 3. Because remember, we don't have to write that 1 if we don't want to. All right, let's do example number 5. It says 3 square roots of 18 plus 3 square roots of 12 plus 2 square roots of 27. Oh my goodness, I have 3 terms here, and not one of them look the same. So it probably is going to be that I have to simplify all of these. So we'll start with the square root of 18. What two things multiply to make 18? One being a perfect square. Yep, you got it. 9 and 2. The square root of 9 is 3. Bring the times 3 down. 3 times 3 is 9. So this would be 9 square roots of 2. Okay, plus, let's do the next one. Break down the square root of 12. That would be 4 and 3. Remember, we're always looking for a perfect square. And 4 is our perfect square. The square root of 4 is 2. Bring down the square root of 3. This says 3 times, so we're going to bring that down into 3 times. 3 times 2 is 6 square roots of 3. Plus, now let's do 27. We did this one earlier. It's 9 and 3. The square root of 9 is 3. So it'd be 3 square roots of 3. Bring the times 2 down. 2 times 3 is 6 square roots of 3. Now when I look at this problem, I'm going to go, okay, can I add them all together? Well, we can't because this radicand's a 2. But this radicand is a 3 and this radicand is a 3. So we can only add the things that look the same. So 6 square roots of 3 plus another 6 square roots of 3 would be 12 square roots of 3. And then I would just bring the 9 square roots of 2 down because I can't put them together if their radicands are not the same. It would be the same thing as if I had 5x plus 7. I can't put the 5x and the 7 together because they're not like terms, okay? So just remember that we're looking for radicands that seem to be the same. And if not, we simplify them to make them the same. So that's all I have for you today. I hope you took good notes, and we will be practicing this in the near future.